Welcome to today's deep dive. If you wanted to perfectly transmit a massive digital file, like a pristine, uncompressed 4K movie, across the length of, say, 2.5 football fields, you might think you'd need a satellite dish.
Right, yeah, that is a massive distance for pure data.
Exactly. But our mission today is to figure out how a single cord actually does exactly that. We're looking at the Celerity UFO-CABLE-750P, which is a 750-foot universal fiber optic extension cable.
Which is wild.
Yeah.
Because, we've moved way beyond just plugging a streaming box into a TV 3 feet away.
Oh, for sure.
We're talking stadiums, massive smart homes, corporate campuses, places that need a constant fire hose of ultra-high-definition video pumped across huge spaces without dropping a single frame.
Okay, let's unpack this. Because usually you just use traditional copper wiring for AV setups, right?
You would, but it totally falls apart at those distances.
Right. I mean, if you push a dense electrical signal through 750 feet of copper, it's basically like trying to shout a really complex password down a massive echoing hallway.
Yeah.
By the time the sound reaches the other end, it's just completely garbled.
What's fascinating here is that with copper, you're literally fighting physics. You get severe signal loss over distance, and the wire itself acts like this giant antenna picking up electromagnetic interference, or EMI.
So, like, that shout has to compete with the invisible electrical noise from every air conditioner and fluorescent light in the building.
Exactly.
Ah.
Which is why this Celerity cable switches to light. Instead of shouting, you're flashing a laser down that same hallway.
Oh, wow. So the data travels instantly.
And perfectly intact. It maintains an 18 gigabit per second data rate. That is enough bandwidth for pristine 4K video at 60 hertz.
Right.
Plus high dynamic range colors, and even the audio return channel, or ARC, so your display can actually send sound back down the same cable to your receiver.
And since it's just transmitting pulses of light, I'm guessing it's physically immune to that EMI noise?
Completely immune.
Okay, but logically, this raises a huge red flag for anyone who actually wires buildings. Well, you're talking about running 750 feet of literal glass through walls and tight conduits. I mean, I've snapped pencil lead just looking at it wrong.
Right, it sounds incredibly fragile.
Yeah, how do you pull a delicate fiber optic strand around sharp corners with 60 pounds of pulling force without just shattering it?
It sounds impossible until you look at the internal structure of the cable. The glass core is protected by this microscopic layer called cladding.
Cladding.
Yeah, it basically acts like a continuous mirror, bouncing the light back into the center so it doesn't escape. And that allows for a super tight 5mm bend radius.
Oh, so the internal mirror handles the light path, and there's a heavy-duty outer jacket for the physical stress.
Spot on. So the internal glass isn't actually taking that 60 pounds of pulling tension directly.
That's clever. But what about getting it installed backwards? I hate snaking a cable through a conduit and realizing it's facing the wrong way.
They solved that too. The universal feature means it's bidirectional. Either end acts as a precision optical pathway for the source or the display.
That is a lifesaver.
Plus, it has detachable connectors, so you're only pulling a tiny plug through the tight spaces.
Right.
And it comes with these UFO protective caps and locking couplers to keep the optical lenses perfectly aligned and free of dust. It's practically foolproof.
They really thought of everything. I also saw it's OFNP rated, which for anyone not spending their weekends reading building codes means it's plenum rated.
Right, it has a special fire-resistant jacket.
Yeah, so you can safely and legally run it through air circulation spaces inside commercial drop ceilings.
Exactly. It covers all the bases for a major architectural installation.
But here's where it gets really interesting, because there is one glaring contradiction in all these specs.
Oh.
We established this is an optical cable transmitting light, right? Immune to electricity.
Yes.
But the manual notes it draws 5-volt power directly from the source component. It even has a little blue LED on the connector to confirm it.
Right, it does.
Glass doesn't conduct electricity. How is a 750-foot cable powering itself without bulky AC wall adapters plugged in at both ends?
Okay, that is the secret to these high-end active cables. They're actually hybrids.
Hybrids.
Yeah. Alongside those microscopic glass fibers carrying the video light pulses, there is a very fine, traditional copper wire running the entire 750 feet.
Ah, so the copper is just there as a power delivery system?
Yes. It sips just enough 5-volt power from your HDMI port to run the optical lasers at each end.
That is so smart. What if the source device doesn't have enough juice, though?
In that rare case, they include a small hardwired USB cable you can just plug in as a backup power draw.
Okay, so that really justifies the $693 price tag. I mean, you're not just buying a wire.
Not at all.
You're getting a self-powered hybrid optical conduit
Hmm.
that flawlessly delivers interference-free 4K video across 2 football fields, totally hidden inside commercial walls.
Exactly. It entirely removes distance as a bottleneck for high-fidelity data.
It really does.
Which really leaves you with something to ponder. If a single hybrid strand of flexible glass can effortlessly push self-powered, uncompressed data through a 750-foot obstacle course, what does that mean for the physical limits of our future infrastructure?
Yeah.
When distance is no longer an obstacle for the signal, just how big and interconnected can we build our smart cities?